Hello and welcome to this course, Tech Users. In this course, we're going to teach about how you can automate security for Linux systems using bash scripting. So we're going to quickly glance over bash scripting. We won't go into all the advanced stuff of bash scripting. We really only need the basics. And then we'll dive into Linux security, how you can make your Linux system more secure using bash scripting. It's a beginner's course. That's why we are mostly focused on beginner topics. So if you're ready, let's go. Hello Linux users and welcome to this video. We're going to teach you about bash scripting. Now don't worry if you're a total beginner, we're going to break it down step by step. So if you're ready, let's get to it. First we'll need to have a Linux terminal. You should already have Linux installed. If you don't have Linux installed, make sure to install that first. What is a bash script? On Linux you can type all kinds of commands. For example, pwd shows you the current directory. You can type the date command and it will show you the current date. So as you can see, it's a keyboard interface called command line interface where you can type commands and it outputs the output of the command. For example, let's say we wanted to echo text or repeat whatever we give it. And you'll see the Linux computer now tells us hello if we use the command echo. And it will, of course, echo everything we want. So you can type all kinds of commands. So, okay, why am I telling you that? Because a bash script, a Linux bash script, is essentially a series of Linux commands. And those can be stored in a file called a bash script. So let me clear the screen here. We are going to make a bash script. Now, don't worry, we're going to do it with a simple text editor called nano. So we type nano and then the name of our script. Let's call it hello world.sh. So you'll see the program nano, the command line text editor. Then our file name and it ends with .sh. See there's already a program here, so I'm gonna give it another name. Let's call it hola.sh. Okay, let's write a script. So as I said, a bash script is basically a series of commands. So we can say echo hello and my first script, for example. Now to make sure that Linux understands this is a bash script, we add a thing called a header. That's basically a line of text that's always the same. And it looks like this. And there you have it, your first bash script. Now, we need to save this. To save this with nano, you can hold the Control key and press O. It will ask your file name. I'm gonna press Enter. And then to quit, hold the Control key and press X. Now, you might think that we can type hola.sh to run it. But if we do that, it tells you command not found. So why is that? We just created that file, right? So first of all, that is because it's not executable. Linux doesn't understand that this is a program. We need to make it executable. And you can do that with this command, chmod plus X for executable, and then the name of your program. And now to run it, we type /, like this, /hola.sh. And you'll see it runs those commands. Those two echo commands are now executed. Now, what if we do it without /? You'll see it says command not found. So you have to type // in front of your script to run it. That's something to keep in mind. So type // in front. You might also try bash with your script. So typing bash in front. That's an alternative, but it's shorter to just type // with your program name. So that is a first script. So I'll show you the code again. So that is the first script. Just it can run Linux commands by commands. And that's basically all it does. A bash script is basically a series of Linux commands. So see you in the next video. Hello and welcome back. In the last video, I showed you how you can use bash scripting, how you can make a basic script that was basically hello world, or any text you would want to output to the screen. Now in this video, we're going to make it more interactive. So what we're going to do is we're going to get keyboard input and then use that keyboard input in our script. Are you ready? Okay, let's get to it. We use nano or another text editor if you prefer. And then the name of our file, which can be really anything, but keep in mind to don't use Linux commands in there. I'm gonna name it chow.sh. Now, Linux doesn't know that we are typing a bash script. As far as Linux is concerned, we are typing a text file. And not typing a text file, right? We are making a bash script. So we add the header of a bash script. Next, we can ask a question. For example, we can ask us, what is your name? Now, we can make this executable. You learned that in the last video. So Ctrl O to save, Ctrl X. And let's make it executable. chmod +x, chow. And then we run it as a bash script. So bash chow.sh or /chow.sh. You'll see it asks your name, but we can't really type anything here. This is the command line. So let's change that. We're gonna open the script again, chow.sh, and we're going to read from the keyboard. Now, as you might have guessed, the command to get keyboard input is read. So we type read, and then we want to read into something, into a variable. So we can store it as name. We want to read a name. So of course, bash doesn't know what name is, but what this does is it reads keyboard input and stores it into a storage, a variable called name. Then we can use that. So we can say hello name. Now you'll see that this is just highlighted all in yellow. So that means that this will just output hello name. And if we run this, if we try to run this, you'll see it outputs hello name instead of hello Frank. So let's open it again. What is going wrong here? So bash doesn't understand that this is not name literally, but it is the keyboard input. So to make bash understand that, we add a $sign in front. That makes bash understand that we want to use the variable name instead of literally name. Now we're gonna save it, Ctrl O and press enter, Ctrl X, clear the screen, and we run it again. Now it asks for a name, and you'll see it outputs hello with whatever your name is. So we just made our first interactive app with keyboard input. You can use multiple variables throughout your script, so you can ask multiple things from the user. Let's see that in an example. So let's say we want to get more information. Let's say a very basic question. And then we say read job. And this is how you would get multiple variables, so multiple inputs. So we get one line of input with name, one line of input with job, and then we say $name to use the first one and $job to use the second one. Of course, you can use this as many times as you want. So you can say, if you want to use this 4 times, output it, you can do it like this. There's no limit to it. But if you would type job without the $, it would output job literally. So you want to have the $sign in front of the things that you get from the keyboard input. That's how bash knows is a stored input or a variable. Now save it with Ctrl O and then press Ctrl X to quit. Run it again. Asks you for your name, and we can say the name of the job, and you'll see it outputs both the name and the job. So that's it for this video. You've learned how to make an interactive bash script. I'll see you in the next videos. Hey there Linux users, welcome back. Today we're diving into Linux firewalls. A firewall is like a guard for your computer, a security guard. It tells you which network traffic is allowed and which network traffic is denied. Now it might surprise you that Linux comes with a firewall by default. If we open a terminal, either using the menu, holding the Control keys, Alt key and T key, Control Alt T, opens the terminal on your computer. So depending on which Linux system you're using. Now it comes with a firewall called Uncomplicated Firewall, or short UFW. So you'll see that UFW, if we just type that and press enter, it doesn't work like that. Let's see first what is the status? Now, to do that, we need to do it as administrator. So we type sudo in front, and then we want to know the status. So we type status. You'll see by default, the status is inactive. Now, I said we can allow and deny network traffic. So we can deny outgoing traffic, so traffic to the internet, but also traffic coming into our computer. So by default, let's block everything. So we're gonna deny outgoing traffic, and we're going to deny incoming traffic. So now anything we do with the internet will be blocked. So very secure, but it also means that we cannot use the internet, right? It's like the most secure firewall ever. Everything is blocked. If we try to open some web page, okay, we forgot to enable it. Remember, sudo ufw status, it's inactive. So let's do that again. Let's enable it. Check the status. And now let's try to open anything that connects to the internet. And you'll see it just keeps loading forever, no matter what website we open, or no matter what we do, whether we use Firefox, Thunderbird, or anything else that interacts with the internet. Because by default, we are now blocking everything. So we can see that with sudo ufw status verbose, and it tells the default is to deny incoming and outgoing internet traffic. Okay, very secure, but also quite useless. It basically means not connected to anything on the internet. Now we might want to allow some network traffic, perhaps web browsing, right? We might want to deny everything, except we could allow surfing the web, for example. It might be completely different depending on your use case. So we're gonna allow the web. Now you might know that on the web you often use HTTP or HTTPS. It's often shown before a web page, https://udemy.com or any other web page. So we're gonna allow HTTPS. HTTP is kind of dated, but you might sometimes still find web pages that use HTTP. Now besides that, using the web is using a domain system. So you can actually type websites, youtube.com, google.com, whatever, instead of typing computer addresses, computer numbers. So the domain system takes care of that. So we need to allow that system as well, which is on communication port 53. So if we allow these three, we'll be allowed to use the web. So everything is completely blocked except the internet. So we can, or except the web. So we can now go to any website, anything you want, and you'll see it opens the web pages. So we can surf the web, outgoing traffic, but remember, incoming traffic is still denied. So it's only for outgoing traffic. So from the internet cannot connect to our computer, but we can connect to websites, but nothing else, right? So we allowed the web, but nothing else. For example, if it's tried to connect to calls, it will be blocked. It's on another port. If it tries to connect, I don't know, some kind of video games, probably will be blocked. So let's check again the rules. You'll see these are our rules now. By default, everything is denied except web traffic. Now this makes sense for a desktop computer. If you run a web server, you might not want to allow browsing the web at all from the server. Maybe you want to block everything except the applications running on your server. So it depends on your use case. But this is how you can use the basic firewall. Now if you want to start over, you can type sudo ufw reset and then press yes. All the rules will be deleted. If you check the status, you'll see active without any rules. So if you made a mistake, you can reset it and all over again. So what you allow really depends on what you want to allow. So by default, it's a good practice to deny everything, incoming, outgoing, and then only allowing what be allowed. For example, browsing the web, maybe video calls with Zoom or Skype, or really depends on what application you're using. Applications All applications that communicate with the internet, they use a communication port or simply port. So you can check that with the command netstat-antop. That command shows you which ports are being used, and you'll see by default that is not installed. So I'm gonna install it, and you can just use that to if you have any applications running, what ports should be allowed. So if I type the command, you'll see only one internet connection on port 80. If I open, for example, the Firefox browser, and let's go to some web page, we check again, and you'll see the web is using port 443 and port 80. Now these are all internet addresses called IP addresses, so it's 4 digits. Interesting part is the number behind that, so that's how you can see ports being used. So we see Firefox here using port 80 and port 443, and it depends on the app. You can find out. You can simply consult a list, so a list of commonly used ports for applications, and see which of those you're using. But that's what firewalls are for, blocking most of the internet traffic, so that you can filter out some of the malicious ones if there is any. Hey Linux users, welcome back. We typed a lot of commands when configuring a firewall. If we just have to do that once for one computer, it's okay. But if we have to do that many times for many computers, it can quickly become a tedious job. For every installation, we would have to type those same commands again. So a better practice is to use a bash script to automate it, to automate that security using a bash script. Now, to make a bash script, we need any text editor. It can be a graphical editor or command line, depending on your preference. Now, because many text editors have a learning curve, I will just use a text editor that is as simple as possible, because our focus here is on scripting and cybersecurity. So I will start a text editor here, and we can type the commands we used before. So we can deny outgoing traffic. We can type sudo ufw deny outgoing traffic. You'll see I typed a comment here on top, so that is ignored by Linux. Anything with a dial sign is completely ignored. We can also block incoming traffic. So similar commands. Okay, so that is the first basics. If this would be our script, it would just block everything. So we might want to unblock some things, which could be the web, could be something else, really depending on your use case. Let's say we want to allow web browsing. Then we can type sudo ufw allow out and then HTTP or port 80, depending on what you prefer. We also want to unblock HTTPS and the domain system, otherwise we cannot use those names. Now the domain system is port 53. If you want, instead of typing those protocols specifically, you can type, for example, 443 and 80 if you know those numbers. So here we have a very basic script. Now bash scripts always start with a header line, and that header line looks like this. So that's just a convention, that's how bash scripts start. So let's save this script. So click Save As, and we're gonna save it as firewall.sh, sh meaning the script, shell script. We save it. You see we got some highlighting, and you'll see what it does. Block outgoing, block incoming, and allow web browsing. Now to run it, we need to make it executable. You can either do that through the graphical interface or the command line. I can open the File Explorer, right click, Properties, and then click Permissions, allow execute file as program. That's one option. So that would make the program executable if you select it. Alternatively, you can do it with the command line. So if we open a terminal, we can make this file executable with this command. Change permissions, chmod, +X for executable, and then the name of the program. Now let's take a look at our firewall status. see, must have sudo in front. It's inactive. Now let's run the script. And let's check our status again. Still inactive. Let's see, still inactive. So we might need to run our script as root to, it's doing sudo commands. See sudo in front of the commands. Let's run our script as root. And then check the status. And you'll see it's inactive. Let's enable it first. Okay, firewall is now enabled. Let's run our script. Okay, and now let's check the status. So all the rules are added. We didn't do any configuration. So there was some tweaking going on. You have to run it with sudo in front. But you'll see all the configuration is there. So it could be like that. Once you have a script, when you need to configure more computers, you simply run the script and it does the configuration automatically. Now, of course, this configuration really depends on your use case. So in this case, we want to allow web browsing. Maybe that's not the case. Maybe you don't want to allow web browsing. Maybe only file sharing or other purposes of your computer. So it really depends. But you can use a script to run commands and to, for example, automatically configure your firewall. Hi and welcome back. Let's do an audit on our system. So let's make a script where we can get some basic information, security information from our system. First, we're going to start a text editor. And then we'll save our script. I'm going to save it as audit.sh. And let's do some basic scripting here. So maybe we want to know who's logged into our system. We can type echo who is logged in. You might know on Linux there's the command who that shows you who's logged in. If I open a terminal with Ctrl-Alt-T, I can type who and it shows you all the logged in users. Now we can do that in an automated way. So this would tell who is logged in. You might want to know about disk space usage. Can do that with command df-h. Might want to know about memory usage. So, and maybe also about running programs, which is really about security. We don't want some bad programs to be running. So if we save this program, we need to add a header to our script that indicates that it's a bash script. So we add that header. Then we open a terminal. And we see our script here. You'll see it's not highlighted in green. This means it's not executable. Or to show some more details, you can type LL. Programs with an X in the end, they are executable. You see here there's firewall.sh and it has an X on the end. Means executable. But with our script, audit.sh, there is no X on the end. Now there's two ways to do that. The most simple way is to open a file explorer, right click, properties, permissions, and then click allow executing the file as program. And if we check, it is executable. Now if you want to do it completely in the command line, you can use the command csmod +x with the program name. That would also make it executable. Now, if we run it, we get some basic security information of our Linux system. So it outputs a lot of information and we have to scroll up all the way. So it tells us about the running programs because we run this command. It tells you about the disk space usage, so all of the disk space information, memory usage, about who's logged in, and so on. Now to make this more readable, we might want to add some separators. So we can add some line in between. And we might not be interested in all of the information. You can modify your script to suit your needs. So let's run it again. And now we have sections in our output. So we can quickly go through our system and see, okay, we have 1.3 gigabytes free memory. We know about our disk space, and we know who is logged into our system. So only the user Ubuntu. Now keep in mind that hackers might use the same username as you are using. So just because you are the only user logged in doesn't mean that your computer isn't hacked. They might simply use the same username as you. However, if you see a strange username with who's logged in, might be an indication of a problem. Hackers might often add one or more users to keep access into your computer, but not necessarily. They might as well use your user account. So with a bash script, you can run one or more commands and can be useful commands for security. For example, instead of memory usage and disk space, maybe we're interested in other things. Maybe we're more interested in the network traffic. So maybe we are interested in network connections. We can type the command netstat antop. Check which programs are connecting to the internet. Now, for this command to work, you need to have the netstat installed. You can install that not with netstat. You'll see there is no package netstat. So to install it, you want to install nettools, and with that program, you can check network connections of programs. So now if we run it, you'll see it tells you who is logged in and which programs are connected to the internet. Now you'll see there is no any program connected to the internet right now. But let's say we open Firefox, and once it's started, let's open some website and run our program again. So you'll see, hey, by running our audit script, we can find who is logged into our computer, but also outgoing connections. So connections to the internet, and we see that there's a Firefox program running, and it's showing some connections to internet addresses. So you can use an audit script to quickly check about the state of the Linux security, maybe about possible indications of the computer being hacked, and as well things that can be fixed or that need fixing. For example, you might discover that you're running out of disk space or running out of memory. So it's a good idea to make an audit script. There's a lot of things you can put in there, which really depends kind of on what you want to achieve as well. Welcome back. Let's improve on our network security or on an audit script. So we might want to first get some general system information. We might want to know, okay, what version are we running? Do we need to update? We might want to know some user information. Maybe not about disk space and memory, but it's up to you. What could be really useful is doing some network security checks. What's going on with the network. You also want to check user permissions or file system integrity. Now that's a little bit more tricky, but it's something you can do. So let's do first a basic audit script. That could be a real world scenario. So we might want to know first, which version are we running? Which Linux version? We can output that in the text like this. So that should output the Linux version. We might also want to know how long has the computer been running. And maybe the name of the computer as well. I mean, if we have a lot of computers, it might be confusing to know which is which, so it can be useful to output the host name. Okay, might want some user information like who is logged into the system. And let's see what this script does so far. So we're going to open a terminal and run it, and you'll see we get immediately some information, and we also see that there is no sections here. So let's add some separator line. And you see, now we see basic system information when we run it. So the Linux version, how long it's been online, and also the name of the system and the users that are logged in. Now, you might want to add a separator line again. And it can be useful to do some network checks. For example, is the firewall running? And we type the command sudo ufw status to check if the firewall is running. So let's run it again. And the firewall, we run it as sudo, so we need to run our audit script as sudo. And then it tells you if the firewall is running or if it's not running. So with audit script, you can then quickly check a complete Linux system about what is going on the system. You might want to know about network information, network activity. So we can do that with the netstat command. Now we get more overview about what is going on in the system. You'll see there's no programs now connecting to the internet. There are some programs, but nothing is connecting to the internet. The firewall is running. Only one user logged in, and for about 1 hour using Linux version 6.2, Ubuntu box. So you can extend an audit script with all kind of commands. Now there are existing scripts, and you shouldn't run any script from the internet. Running a single script can mean your system gets hacked. So you always want to write your own scripts. But it can be useful as reference to check at other people's scripts, as long as you don't run them, because there might be a backdoor in them or some malicious malicious commands. So you always want to write your own bash scripts. Welcome back, Linux users. It might surprise you, but there's lots of malware for Linux, lots of malicious software, viruses, kits, reverse shells, and lots of other things. So it's a good idea or a good practice to check for viruses or malicious software on Linux. One of the ways to do that is with the clemav program. So first you'll need to install that. So the program is called clemav. It's a command line program. You can install it with your package manager. Then it will take a moment to install. So the program is called clemav. But if we want to scan the computer, we don't use the command clemav, but we use the command clemscan. So clemscan. Then we want to scan not just the main directory, but also all of these directories, downloads, music, pictures, and so on. So we need to do a recursive scan and then specify the directory name. Now, with the File Explorer, you can press Ctrl L and copy the directory name. Paste it in and press Enter. And it will scan all the files in your computer. So, depending on the computer, it will scan everything, and it takes a while, so every file is scanned and checked if it is a malicious software or not. Of course, it's not just software that can be malicious. It can be Office documents that contain malicious scripts. For example, Excel or Word files. It can be programs, it can be zip files that contain malicious software, and so on. So with this program, with the command clemscan, you can scan a directory on your Linux computer, and this R flag is necessary because it means to also scan all the directories under the home directory and not just these two files. So it scans every file and compares it to a database of like 2 million virus signatures. You see it scans subdirectories. In this case, there is no infected file found. That means there is no malicious software or virus present in the form of a file. Now, important to remember that some malicious software doesn't store on the file system. So some malicious software is in memory only and not on a file. However, a lot of malicious software is file-based. So it's a good practice to scan your computer regularly for any kind of malicious software. If you have a script, you might want to run it once in a while. For example, every day, every week, or once a month, just with a certain frequency. Now, before we just run scripts manually. For example, when we wanted to configure the firewall, we would type /firewall. Now, what if you want to do it not manually, but automatically? You can use crontab for that. So we type crontab-e. That's a program for Linux that allows you to schedule programs. So if we type crontab-e, you get into a command line editor. And here we can specify which command to run with which frequency. Now there's an example here on top. Let's say a backup of the accounts, so they do some commands here. So here we have the frequency. So at 5 AM every week, it is run this command. So M is for month. Then we want to do it at 5 AM, for example, every week. We could use the same command. And then we specify our clam AV scan. So you could specify a command like this. It will scan every week at 5 AM. It will run clam scan, so the antivirus scan your whole home directory, and then save the output to a log file. So if we save it and close, now it will run every time at 5 AM. You see it installed a new crontab. Command is now run every week at 5 AM. So it depends on what script you want to run, and of course you can change the time with these parameters. But it can be used to run scripts regularly. Now it's important that you specify the correct paths, otherwise the script won't run, or the program won't run. So that's important when you're working with cron jobs. Cron job is not the most easy tool, but it can be useful for doing tasks that have to be done with a certain frequency. Welcome back, Linux enthusiasts. You might be inclined, or you might download scripts from the web. It's a really bad idea to do that. For example, here we have a script called fun.sh. Could download scripts like that from the web. Let's say we make it executable, and then we open a terminal and run it. So fun.sh that we downloaded from the web, and let's run it and see what happens. So it looks like nothing's happening here. But let's take a look from the hacker's computer. They got a shell into our computer. So we run a script from the web. And by doing that, we are now inside this Linux computer. We can browse around and see, for example, all the scripts that we have been making. We can go into directories, and basically we have control over the computer on the same level as we were. So we are user Ubuntu, and the hacker is also user Ubuntu. The only thing the hacker needed to do was to wait for the user to run that script. So never run scripts from the internet. Always make your own scripts, because if you run a malicious script, it can take over your computer without the hacker doing any effort. All they need to do, the user, is to run a bad script, and you can then look into their computer, mess around with the file system, and basically do the same things as you would do on your Ubuntu computer. So just give them access into your computer by running a simple script from the internet. So never do that. Always write your own scripts. Now you might think this is a really complicated thing going on. The script is actually really basic. So if we take a look at the script, it's just a one-liner command that opens a connection to the hacker's computer, and then the hacker is waiting for a connection on port 4242 with this command, so it listens for a connection. User connects to the computer to the hacker's computer with this command. Of course, the IP address must be the IP address of the hacker's computer. But basically, it's not like there's a lot of complicated things going on, it's just giving the hacker access into the computer called the reverse shell. So never run scripts from the web, because you see, running a script from the web, the hacker has access into your computer. Always write your own scripts for security reasons, because even if you really tighten your computer security, and if you run one malicious script, it can be your computer is compromised. So that's it for this video. It's just a quick tip.